Welcome back. In this lecture, we will solve an assembly problem using the AutoCAD Inventor software. So, let us get to the problem. Here is a duct assembly which has 4 parts. So, first we will try to understand the problem and then go into the software to see how to assemble this. So, first we see that there are 4 parts, starting with the bottom part which is like an L shape, and the second part sits right on top of the first part, and third part and fourth part you see that the axis of it are all vertical and they align together. So, essentially all these 4 parts are sitting one on top of each other. So, we also have an exploded view to give us a clear idea about how we are assembling these 4 parts. So, as we already mentioned, these all come close to each other and they are all aligned in one vertical axis. So, we also have the part drawings of each of these parts, starting with this is part 1, which is the bottommost part. Second is part 2, which is in between this part 1 at the bottom and part 3 at the middle. Next is part 3, which is again on top of parts 1 and 2. So, it is second from the coming from the top, and lastly we have this part 4, which is sitting on top of all the 3 parts. Okay. The reason why we are showing all these 4 parts is so that you can pause at this video and spend some time in developing these parts. For me, I have already created this part, so that I thought I will save some time when we can focus more time on assembling these parts. So, let us get back to the question, and now I will move to the software to see how we assemble this into a assembly. So, here we are at the initial interface of the software. Let us open a template, assembly template of standard mm.iam. We will be following the bottom up approach, where we have already created the part models, we need to bring them into the assembly environment. So, for that we go with this place tool and select these 4 parts, parts 1 to 4, and select open. So, let us place this here and right click and say OK, since we are only looking at one component of each. So, these are the 4 components we have. First thing we need to do is one of these components we need to ground it, such that we restrict all the degrees of freedom for one component, and later one at a time we will move into each of these other 3 components to constrain them. So, I am choosing the bottom part 1, right click and say grounded. So, now I have the part 1 which is grounded or constrained. Now, let us get started with part 2, so that it is properly aligned with the part 1. So, we will make this top surface of the part 1 and the bottom surface of part 2. Apply. And then now to bring this part 2 close to part 1 and to align it, I will use the flush, where I will select this face and this face and apply the constraint. We still see it is not properly aligned, because then we need to use one more flush between this face and this face. Okay. Now, it is properly aligned, we are done. So, we need to apply the constraint, and then it is the part 2 is properly aligned with part 1. So, we can go to the degrees of freedom analysis and check that both part 1 and part 2 are completely constrained. So, now we can move into part 3 and 4. So, what I will do is, just to have a good contrast, let me change the select part 3 and change the color. Okay. So, we will move this close and try to understand how to constrain this part 3 with respect to parts 1 and 2. So, for that let us go back to the problem. So, we notice that there are holes in this part 3. These holes also match with the holes there which are present in part 2. So, we need to ensure that the axis of these pair of holes match between part 2 and 3. So, let us look here, we see that these are the two matching holes which have an axis, and similarly part 3 also have those matching holes which have an axis. So, we can go to constraint, choose that. So, I have chosen the first axis from part 2 and then second axis from part 3. So, it is showing a preview of how it will align both these axes, which looks fine. Let us apply. Okay. So, now we see that I can move this along the common axis. It has 2 degrees of freedom, one is the translation and the other is this rotation. So, how do we constrain this? So, for that what we can do is we can define the angle between, let us say, this face of part 2 and this vertical face of part 3. So, we will go to constraint, define the angle using directed angle. So, I will choose this face from part 2 and this face from part 3. Now, both of them we are saying they are parallel to each other because the angle is 0. So, let us apply the constraint. Similarly, I will do the similar 0 degree angle between this face of part 2 and this face of part 3. So, let me select face 1, face 2 and apply. So, now it is vertical. Lastly, what I need to do is I need to mate this face of part 2 with the interior of this part 3. So, let us select this face from part 2 and the interior of part 3. Let us zoom in, okay, and apply. So, now we see this part 3 is properly aligned with parts 1 and 2. So, we can go and check the degrees of freedom. We notice that for part 3 all degrees of freedom are constrained now. Lastly, regarding part 4, again what we will do is we notice that there are again this pair of holes in part 3 and this pair of holes in part 4. If we align both the axes, we can constrain couple of degrees of freedom. So, first let us go to constraint, we are in mate, let us select this axis from part 3 and similarly let us zoom in and select the axis from part 4. So, okay. Now, we see that both these axes are aligned, let us apply the constraint, but we still notice that the degree part 4 will have few degrees of freedom, one is the translation and the other is the rotation. One way to constrain both is we know that part 4 has an axis and part 3 has an axis, the vertical axis. If we align those axes, both these degrees of freedom will be constrained. So, for that let us again go to constraint, select the axis for part 4 and the axis for part 3. So, once we constrain that and apply, we can go and check the degrees of freedom. Now, we have constrained all parts 1 to 4 in all degrees of freedom. Okay. So, now we can go back to the question and see that so the assembly which we are aiming to get it is exactly matching with what we have done. So, we can save this assembly, let us say I will save it as assembly 3 and then we can open a drawing template to extract the views of the assembly. So, first let us go to base, since the assembly is already open, it is selecting the previous one. Let us place it at the center, and maybe we can go with a enlarged scale. So, let me keep it here. Okay. So, now we have extracted one view of this assembly. We can go for a section view by first selecting the base and then specifying the section line, right click, continue. So, we can place the section view here and done. So, in this lecture we have started in the bottom up approach, where the 4 parts were already created. So, we imported those 4 parts into the assembly environment and then applied constraints to assemble all these 4 parts together. And after saving that assembly template, we opened the drawing template and extracted a view as well as the section view. So, with this let us conclude the lecture. So, thank you for your attention.